Hello and welcome back. Today we'll be going over how we plan on using an AStar grid to allow our little guy here to move around towards any location that we choose whilst taking into account the terrain difficulty, i.e. how hard it is to walk over certain types of terrain. Now we're going to be using AStar for this pathfinding, as I said, and it is really simple. So we're just jump straight into it, I guess. The first thing we want to do here is we're going to create a new scene. Oh, I should actually mention very quickly, what we have here is just a tile map with nothing on it and just a player with no script. It just has a camera and a collision shape attached to it. So to start, what I want to do here is under the tile map that I have set up, I want to go down to custom data layers and add a layer. Now I'm going to name this layer path_cost. Now, what path cost is more or less the higher the value, the higher it's going to, or the more it's going to cost for the character to move over that. Now, this isn't like you have X amount of thing. This is just more of the algorithm will take into account how difficult a terrain tile is by that number and path around it if there is a better, shorter path. So I'm going to set this to an integer. I'm going to hit Control S and save. Now I'm going to come down to my actual tile map here, or under tile set. I'm going to go to paint, property, and then I'm going to come down to custom data path cost. And for now, I'm just going to set everything that I'm using on this grid as a path of 1. So 1, 2, and 3. So these 3 tiles are all that I'm using, right? So these will all now be the same cost. We'll change this in the future, but for now, this will work. So let's hit Control S and save. Let's go back to that new empty scene that we created. This is going to be of basic node type because it doesn't need any extra node 2D related things. It can just be a node. I'm going to call this the Pathfinding Manager. I'm going to hit Control S. I'm going to go and save this under my scenes, under main, under a new folder called managers. Now I'm going to go and add a script to it. Create a new class for this so it can be referenced easily. So Pathfinding Manager. Now let's get rid of the function process because we don't need, we'll need the ready function, but we won't need it just yet. First thing I want to do here is create a constant. Now the constant is just going to be for storing that string name of the path cost. So when we come to use it in the future, we don't have a magic floating string. So I'm just going to call this path cost. Call it path _ cost. I'm already doing this slightly wrong. There we go. So that's our new constant variable setup. This just means it can never be changed, which is nice. So to start with AStar grid and pathfinding, the very first thing we actually need to do here is create a new variable for the AStar _ grid. This is going to be of type AStar grid 2D. We're going to set that equal to the AStar grid 2D dot new. This is just going to create a new AStar grid for us to work with. Final thing we're going to be needing is, actually there's 2 more things. The first one is going to be the array that we plan on setting and giving around to whatever wants to move. So we're going to need a path array. It's going to be of type array, and this is specifically going to be a array of type vector2i. So we're going to be using 2i for this because AStar works very well with vector 2i. And I'm just going to be setting this to an empty array. And the final thing here we're going to need access to is the tile _ map _ layer as an exported variable. Now, the reason we want that is because this allows us to do a lot of easy setup. There are many other ways of doing this and getting access to this data. This is just the preferred method that I'm going to show off for this video. Let's create that ready function again, and then write pass. And then just below it, we will create a new function, and it's going to be called func_set _up _grid. And what this function is going to do, more or less, is, as kind of the name implies, it's going to set up the grid. Now, what do we actually need to set up the AStar grid? Well, if I click on AStar grid here, you'll see right here, to use AStar grid 2D, you need to set the region of the grid, optionally set the cell size, and then call update. So this is more or less what we want to be doing, right? So to do this, we're going to go into the Pathfinding Manager again. And first we're going to call the AStar grid.region and we're going to set that equal to the tilemap date or tilemap layer dot get underscore used rect. Now this is going to, with how my tile is set up, this is going to grab every single tile I've placed and just use that as a rect. Now you're going to want to be more specific with how you set up your layers and things like that, but for now this is kind of the simplest way for me to do this. The next thing is grabbing the AStar grid dot cell size, because this is a kind of important one to set up, even though it says you don't really have to. Now we're going to grab the tilemap data or tilemap layer dot tile set dot tile size, and that will give us our cell size. And then finally, a little thing that I always want to add onto this is AStar grid dot diagonal mode, and then set that equal to AStar grid diagonal only or diagonal mode only if no obstacles. Now I'm going to control and click on this, and it'll say here only if no obstacles. The pathfinding algorithm will avoid using diagonals if any obstacles have been placed around the neighbor cells of specific path segment. This just basically makes it a little bit cleaner. You can do, there's a lot of different modes for this, there's a lot of different cell shapes, there's just a lot of different stuff you can do with AStar in general, but this is pretty much the AStar setup. Now if you remember correctly, we just need to call one final method in here, and this is the dot update function. That way we can set up our grid. Now under ready, I'm going to call that new function for setup grid, and we're going to set up one more function. So there's two more functions in total we need to do. The next one is just going to be setting up the kind of movement cost of each tile, so we can actually get valid data on how we want to move. So we're just going to write a new function, and we'll call this set underscore terrain underscore movement underscore cost, void return type. Now to do this, I need to basically grab two things. I need to grab the position of the cell and the data from the cell. So I'm going to go for cell underscore position in the tilemap layer dot get underscore used cells. So what that's going to do is grab every single cell we've used and then return a vector2 position. I can click on that and it will tell you right here, returns a vector2i array with the positions of all cells containing a tile. So we're getting a vector2i array. I'm going to go and create a new variable here for the cell data. So we're going to need that next, right? So cell data, I'm going to set that equal to the tilemap layer dot get underscore cell underscore data, cell tile data, and pass through that cell position. So now we have all of the data on this tile, or whatever tile that we're looking at right now, which could include, of course, things like custom data, right? So this is how we kind of access that custom data. So I'm going to break it down one more. I'm going to go cell underscore path underscore cost, which is going to be an integer of, and we're going to set that equal to the cell data dot get underscore custom data, and then we're going to pass through that original constant variable we made, the path cost. I have not spelled that correctly. Path cost. That's wrong. There we go. That's right. There we go. So now we're actually getting the cost of all of the tiles, right? So it will be a bunch of zeros and then the odd one, or like there will be 3 ones in this array, basically. Now what we want to do is grab the AStar grid and use dot set underscore point weight scale. Then this is going to need the position, or the ID, so the position, and then the weight that we want to set. So I can just pass through the cell position and the cell path cost. And now in my ready function, I can once again call setup or set terrain movement cost. Now we have our grid and we have all the movement values kind of attached to that setup. The next thing I want to do is just create a little function that will return an array going from one point to another. That way we can start handling movement. So this is going to be relatively simple, right? We're just going to use create a new function, call it get underscore valid underscore valid, there we go, underscore path. And it's going to need to take in 2 parameters, the start position and the end position. So this is going to be start underscore position of vector2i and an end position of vector 2i, and it's going to need to return an array of vector 2i, right? Because that way anything that accesses this method will be able to actually get a valid path, and it's not just tied down to, say, like just the player or something like that. Anything that actually wants to touch this can now grab a valid path. So to get this valid path, we just need to go for point. So for the point inside of the AStar grid function that we want to call. So in AStar grid dot get point path. This is going to basically just be a path of points. We want it between the start position and the end position. Let me create some space. There we go. So between the start position and the end position, we need to grab the current point. I'm going to basically do a little thing that I like doing because it centers the character just a little bit more without doing anything weird. I'm going to go current point, which is equal to a vector 2i, and set that equal to the point. Then I'm going to grab my current point and I'm going to increment it. So the reason why I'm doing this, right, is what this will do is adding. Yeah, let me show you the full thing first. Tile map layer dot tile set dot tile size divided by 2. So what this is actually going to do, right, is it's going to take our current position and it's going to divide it by 2, which will center the character on each tile. So the point we're actually looking for isn't the top left corner, the origin. It's actually going to be the center of the tile. That way it's a bit more clean. And now for that point, we can just append it to the path array, right? So we can just go path array dot append and pass through the point. Oh, sorry, pass through the current point. And then all we have to do after this is just return the path array. There you go. We now have, like, this is pretty much the full AStar grid. Now, I haven't actually shown it working, but I'll do that in a second. But for now, like, this is really, really simple, right? You have the basic setup. You then have the setup of the movement cost afterwards. And then you finally have the getting the valid path. And this is just a function that anything else can access and just be like, hey, give me this path. So I'm going to hit Control S and save. And let's actually get this kind of running correctly. Now, to get it running, we're going to need to go and set up a player. I'm going to just attach a script to my player here. I'm going to remove all of this because it's not needed. I'm out of habit going to apply a class name to the player, call it player. And we're going to need some variables. We're going to need we'll just do a normal var. Call it movement underscore speed. It's going to be a float, and we'll set it equal to 50. Then we're going to need a var for the path underscore array, so the array that this character actually needs to use to move around, which is of course going to be an array of vector 2i. And then it's going to need access to the Pathfinding manager. So there's other ways we can do this. But what I'm going to do is set this up in a very, very shallow way so you can get the idea and the concept of it. And in the future, if you want to know how I would actually set this up in a large project, let me know and we will dive into it in a much more deeper way in the future. Yes, for now, we just need access to the Pathfinding manager. Path, I can't spell today. Underscore manager of type Pathfinding manager, set that equal to null. And this is something that I'm going to do. You don't have to do this. I'll kind of show you how it works afterwards. This is just a little debug line thing that I set up beforehand to show the pathing off. So what are we going to need? Well, we're going to need access to the process function. Technically speaking, the physics process function, but the process function will do for now. And we're of course going to need to go into our project settings, go to the input map, and I'm going to add a new action here for left underscore click. I'm going to set that to my mouse button because I want this character to basically move to wherever I click my mouse. So I'm just going to run a quick, actually, better idea. Let's just create another function here and we'll just call this the unhandled input. and we will go if event dot is action pressed, left click. Then we want to first grab that path array and clear it. This is a very important thing to always do, is make sure you clear your path array. Otherwise you will just be stacking path on path on path. So every time it moves, it needs to, or every time you want to set a new path, it needs to clear the old one. So always remember to do that. And then I want to grab the path array dot, or sorry, set that equal to the pathfinding manager dot get valid path, which is that function that we created that allows us to, get a point between the start position and the end position. So I'm just going to pass through the global underscore position. I'm going to do some fancy math here. I will explain why in a second. By fancy math, it's not really fancy math. What I'm actually doing here is I'm dividing the global position by the cell size to actually get a proper grid coordinate. So make sure to do that. And then we are going to want to grab the get global mouse position as well and do the same, divide it by 16 since 16 is my cell size. Just remember, this is my specific cell size for my tile grid. If you're using a 64 by 64 cell or 8 by 8, that's what this will be. Mine is just set to 16 for now. But with the unhandled input being handled, under process now, what we can do is we can just go if the path array dot is empty. So if it's empty, I'm going to do an inline return here, or a single line return. What that usually looks like is this. And then I want to go and set up a new function. Now I'll explain why I'm doing that return in a second, right? So this new function is just going to be called move underscore to underscore position. It's going to take in no parameters and be of void return type. And now I just need to do some really, really simple checking, right? First thing, I need to go if the len, or length, of a path, or of the path array, is greater than 0, I want to do something, right? So we actually need to make sure we have a path for this to function, which is kind of what this if check is doing. So what I'm going to do is I want to grab the direction, which is a vector2, and I want to set that equal to the global position dot direction 2 and pass through the path array 0 point. So basically the point that we want to move to first. That is the 0 point, and that is what our direction is going to be. So we now know which direction we want to move in and where we want to go. So all I have to do now is just grab the velocity and set that equal to the direction times the movement speed. Now, as a friend of mine has pointed this out in a few videos, usually what you see a lot of people do, and myself included, is they will then times this by delta. You do not need to times this by delta if you're using a character body 2D, and the reason for that is if I just come down to my process function here and call move and slide, well, what happens is move and slide is already calling delta, so you don't need to do delta. That basically just means if you do delta, like times this by delta, then you are applying delta twice, and that's just a bit weird. It basically just means it ends up really, really slow. So we are now calling move and slide, and let's also just call move to position here as well. We aren't actually done setting up the function though, I'm getting sidetracked. So what we want to do now is inside this if statement, we want to create a new one. We want to go if the global position dot distance to the path array, we want to pass through that 0 point, is less than or equal to 10, which basically just means if it is less than or equal to 10 distance units away, we'll call them distance units, then what we want to do here is grab the path array and then use dot remove at, and we want to pass through that position at 0. And now for that little signal that I made, I just want to go and call that. So update debug line, dot emit and pass through the path array. And finally, outside of both of these if statements, we want an else statement. And this is just going to set the velocity equal to a vector2 dot 0. And now that is pretty much set up. That's pretty much all we have to do. So I'm going to click, I'm not going to click play, I'm going to go to main. I'm going to add a new container here of node. I'm going to call this the manager container. I'm going to set this all the way to the top. This is usually where I like my managers to be, at the very, very top of the tree, closest to the root. Then I'm going to use Control-Shift-A. Okay. I'm going to add the Pathfinding manager into that. I'm going to assign its tile map layer. And then I'm going to assign the Pathfinding manager to the player. And finally, one last thing I want to do here is if I go to my entity container and click the script, this is the little draw functionality that I set up. This is basically just going to be a line that will go from where we are to the point that we want to go. It's going to be a red line of 5 width. This is relatively simple. I'm more or less what I've got to do here is if I click on my player now and go to node and signals, you'll see the update debug line path signal. I'm going to left click on the entity container, click pick, and then attach it to the debug draw signal. And that's now going to, every single time we update the path, i.e. we remove a point from the path, it's going to call this function, and it's passing its own path inside, right? And then that's going to call redraw. Then all we're doing is checking if the length of that path is greater than 0, and if it is, we are doing a for loop. For point in range of the length of the debug path -1, we then just want to draw a line. And that's it. That is a simple little pathfinding line for you as well. So with all of that done, I should be able to hit play and pray that nothing breaks. And there you go, nothing is breaking. And as you can see, we are now pathfinding around. The little debug line that's drawing is telling us where we're going and what we want to be doing. As you can see, there is just kind of no weight to any of this, right? It's just kind of pathing along as much as it can without taking into the terrain, or taking the terrain into consideration. So to change that, we're going to go back to the tile set, go back to the path cost, and I'm going to set, let's go 3. I'm going to set the slightly rough dirt to 3 here. I'm going to set the, actually let's do 25 on that one to make it really, really avoidable. Let's do 6 on the normal dirt, and then let's do 1 on the path tile, or this little cobble tile here. So now when I click play, what should happen is you'll see it's trying to stick to the paths as much as it possibly can, because these are the preferred pathing. And that is just really cool. And it will try to avoid, as you can see there, it's now trying to go off map because I've set these to 0. But it's trying to more or less avoid all of the terrain that is too difficult to pass through. Now that's really cool because it means you can actually start applying things like modifiers and other things to your character as they walk through certain terrain. Now that's kind of going to be all for today. If you want a more in-depth guide on how we can actually put what we've learned to use and do more with it, please let me know. Make sure to comment, subscribe, do all the liking things. And as always, have a good day and a great game dev journey.